at this. So basically here we have this problem that's talking about supply and demand. So what's really world centered on this type of deal is, so with COVID and everything that's going on right now, like a lot of you probably don't know, but the price of lumber has like skyrocketed in the last few months. So like my husband is in construction, and a 2x4 at Lowe's or Home Depot, what used to cost like a little over $3 is now costing over $5. Okay, and it's all this supply and demand of when we closed certain areas to where we couldn't trade and import things in. Suddenly we have this supply problem where we don't have as much as we need, and we can jack the price up because people need it that badly. Okay, now it's something that will level out over time, but for now we have this kind of fluctuation in price that's going on. That happens a lot. This particular problem is talking about the price of gasoline. Just in my lifetime, the prices of gas fluctuate all the time. We've had highs, we've had lows, and that's going to continue to happen because that happens with oil all the time. Okay, so what we're going into is we're going to talk about systems of equations, and we're going to talk about some different methods that we're going to solve systems. The first one is by graphing. Okay, so if we're looking at this problem, we have these two functions. We have a demand function and a supply function. Both of them have been graphed on here. And what we're looking for is the place where they come together. Okay? So where the two lines intersect, that is going to be the solution to the system. Okay? So the question you were supposed to answer on number 1 was find an approximation of the coordinates of the intersection of the supply and demand functions and explain what that point represents. So what's some points that we put? Say that again. Okay. Anybody put anything different? 9.2. 3 point what? Just did 9 and 3. Are these all right? Okay, so we're talking about an approximation in this case. Approximation is telling me I'm not going to have some exact answer. I'm approximating it. Okay? So for this one, any of these 3 answers would have worked. Okay? So I want you to think about what that point is representing in the context of the problem. All right, so what's the x value representing? Okay, so barrels of gasoline, right? Millions of barrels of gasoline. So that's not 9.3 barrels, that's 9.3 million barrels of gasoline, right? Okay, and then what's the 3.5? The price in dollars, so that's really like $3.50, right? Okay, so the point where they're coming together, what is that? What's the purpose of that? Say that again. Okay, so it's where our supply is matching our demand. Okay, so I don't want to over purchase things. I don't want to under purchase things, right? Because that costs people money. And so if I can figure out where my supply and my demand are going to come together, then I can have a better idea of how I need to purchase things, how I need to price things, and that's going to save money in the long run. Okay, so we're talking about where supply and demand are coming together. Okay, I want you to turn to that next page, and I want you to plot the lines on those three graphs. We are going to do that other question. I just want to do all three graphs. All right, so if we look at this first one, okay, so I'm going to kind of zoom through the graphing because I'm making an assumption that we know how to graph a line. First of all, because we've already talked about it and you learned it in algebra 1. Am I making a correct assumption or do we need to talk quickly about lines? Okay, so when I'm graphing a line, I'm going to plot my y-intercept, right? Which is this number, okay? Then I'm going to use my slope. In this case, it's 1. So that would be 1 over 1. So rise over run. So I plotted 1. Then we went up 1 over 1, up 1 over 1. And drew that blue line. Okay? Then we have a y-intercept of 4 with a slope of -1, which is down 1, right 1, down 1, right. Okay, so we have these two lines that come together at a point there. Is that point exact, or is that going to be some kind of decimal? Some sort of decimal, right? Okay. How many solutions is that graph going to have? 1. Okay, so that's one solution. So it says, what problems can arise when solving a system of equations by graphing? Okay, so if the point is not whole numbers, we're going to have a very hard time getting the exact answer of what it's going to be. Okay, so if our answer is not whole numbers, graphing poses a big problem with figuring out the solution because we're basically just guessing. And you do not want to guess. All right, so B. B should look like this. What kind of lines are these? Parallel. Okay, these are parallel lines. Parallel lines. Give me a definition for parallel lines. Huh? So they are linear. Lines that are never going to intersect. Okay? Yes, they have the same slope. Okay, they're never going to intersect. They have the same slope. So if I know that my solution is where the graph intersects, and I know that these are parallel, what solution is this going to be? It's not going to have one, right? So we're going to say this is no solution. Okay, then we get to this last one here. To be able to graph this second line, what do I need to do? Okay, divide everything by 2. So I get 1 plus 2x. Is 1 plus 2x and 2x plus 1 the same thing? Yes. Addition is commutative. What does commutative mean for bonus points? Say that again? Okay, so order doesn't matter, right? Okay, and those are imaginary bonus points, by the way, which you got. Congratulations. Okay, so commutative. So addition is commutative. What's the other operation that's commutative? Multiplication. Okay, when order doesn't matter. We're not going to do this question. I'm not going to make you classify any of it. All right, so let's move down to number 7. Marlon is buying a used car. The dealership offers him 2 payment plans as shown in the table. Okay. Marlon wants to answer the question, how many months will it take for him to have paid the same amount using either plan? Work with your group or parts A through F to determine the answer. So I want us to start with question A and B. All right, so I want you to write the 2 equations that go with the information from the table. Okay, so this is kind of 2 different scenarios. So one is more of like a traditional scenario of how you would buy a car, and then the other scenario is like those deals that you hear on the radio all the time about how they're not going to make you put any money down and they're not going to give you a credit check and all those different things, right? Um, realistically, when you're buying a car, you're going to want to put money down, because if you don't, and the payment's higher, you're going to end up paying more money over the term of your loan. Okay, so first one is a $0 down payment with a $300 monthly payment. So write an equation that models that. So we're going to have y equals what? 300x. Okay, second one is $3,600 down payment with a $200 monthly payment. Good. All right, so to write it as a system, all right, so now we're going to graph it. So we have y equals 300x. Okay, so with this big of numbers, what's my y-intercept here? 0. Okay, so I know that I'm going to have some point at 0, 0 for this particular one. Okay? My slope here is 300, but what's my graph going up by every time? So each tick mark is actually 900. Okay? So if I have this slope of 300 over 1, if I wanted to make it 900 over something, what would it be? 900 over 3. Okay? So this is one way that we could do it. We could change that slope, manipulate that slope to where it's something that we can use. Okay, so that would be this scenario. Okay, another way that we could have done it is, let's say I want to figure out at 6 months how much I've spent. How would I do that? Okay, so we could plug in 6 for x, and that's going to be 1,800. Okay, so that's another way that we could do that. Either way works. Okay, the other one was 200x plus 3,600, right? Okay, so here we have a y-intercept of 3,600. And so if we have this slope of 200, what can we turn this into to where it would actually be something we can calculate? We could do 1,800. Okay, so 1,800 over 9. Okay, so 1800 is like 2 tick marks, right? So if I went from here and I went 2 tick marks, and then I got to go over 9. Then I went up. 369. Okay, and like I said, if manipulating the slope is confusing, then I can plug numbers in. Plugging numbers into this one gets kind of difficult at times because you just got to know you're going to have to test some numbers until you get one that's actually on the graph. Another thing that you could do is if I have my graphing calculator, how can I use my graphing calculator to help me with this? What features? Where can I get points from a calculator? Okay, so I can graph it and I can go to the what? Okay, so I could do that on the calculator, but what if I'm trying to plot points? Yeah, you go to y equals. So if I go to y equals and I type in this equation, it's just going to pull up the line. Where can I find a list of points? The table. Okay, so you can use your calculator, pull up the table, plot points from the table is another way to do it. There's a lot of ways that you can do a problem like this. Okay, so it says, what is the solution to the system of equations? So what's the solution here? Okay, 36, 10,800. The point where the two lines intersect. 36, 10,800. Okay, so it says, what does this represent? What's the 36? 36 months, 10,800, the amount of money spent over time, right? Okay, so where those two lines come together is the point where the two plans are the same. You would be paying the same amount of money for each plan. Okay, no matter which one you did. In how many months will the total cost of the two plans be equal? That's 36. Okay, and then I want you to look at number 9. It says, if Marlon plans to keep the used car less than 3 years, how many months is 3 years? 36, okay? So picture less than 36 months. Which plan is going to be smarter? Plan 1, okay? The $0 down payment. I'll tell you, like, in mostly all cases, putting a down payment down is going to be what you want, because realistically, your interest rate that you're going to get for each plan is going to be the same. And if I choose the same amount of months, like if I'm going to go out the same number of months, I'm going to end up paying more money if I don't put down a down payment. Okay, so this next page, you guys have this written down. I want to go through this though. All right, so during 1 year, Sarah invested $5,000 into two separate funds, one earning 2% and another earning 5% annual interest. What does annual mean? Yearly, okay. The interest Sarah earned was $205. How much money did she invest in each fund? Okay, so the first thing that you're doing when you have a real life scenario like this is you're going to define your variables. Okay, so they've done that. X is going to be fund 1. Y is the amount of money in fund 2. Okay, y'all get your heads up, please. Okay, so then you want to write your two equations. So she invested a total of $5,000. So X is the amount of money from fund 1. Y is the amount of money from fund 2. If I add those together, I'm going to get my total amount. So we have X plus Y equals 5,000. Then the second one is talking about the interest. Okay, so she's paying 2% interest. 2% as a decimal is 0.02. She's paying 5% on the second fund, which is 0.05. And she earned $205. Okay, when you're doing percents, if you're going percent to decimal, just move the decimal 2 places. All right, so we're going to solve this using what we call substitution. Okay, and so essentially what we're going to end up doing is we're going to solve one of the two equations for one of the variables. Does not matter which variable you choose. Choose the one that's easiest to solve for. Okay, so which of those is going to be easier to solve? The X plus Y equals 5,000. Okay, now because it's just X plus Y, and there's no coefficients in front of one of them, either variable is going to be just as easy to solve for. Okay, but if it was like something like this, X plus 2Y equals 5,000, the X would be easier to solve for because it's less steps. All I have to do is move the 2Y. I don't have to divide by anything. If I solve for Y, I'm going to have to move X and I'm going to have to divide myself. Okay, so just whatever is easiest. So if I'm going to solve for X here, okay, so let's say I'm going to solve for X. What would I do? Okay, so on your paper, did they solve for Y? They solved for Y? So let's solve for Y just so we can check ourselves. Okay, so Y equals 5,000 minus X. So what you're going to do is you're going to take 5,000 minus X, and you're going to plug it in where you see Y in your problem, in your other equation. Okay? So we're going to get this. So now what we've done is we've made it where we only have one variable. And if I just have the one variable, then I can actually solve it. What is 0.05 times 5,000? Says it on your paper. Okay, and then 0.05 times negative X. Okay, then we'll combine like terms. Then we will subtract 250. 205 minus 250 is going to be negative 45. Then we would divide. We actually get 1500. Okay, so I have my x value. Once I get one of the variables, I'm going to take that and I'm going to plug it into one of my original equations to get the other variable. So the x plus y equals 5,000. To me, that's the easier one to plug something into. So we'll subtract 1,500 from each side. And we get y equals 3,500. How would I write this as a coordinate point? Okay, 1,500, 3,500. What does this mean? Okay, so $1,500 was invested into the first fund. $3,500 was invested into the second fund, and that's what earned her that interest of $205. Okay, I want y'all to go where it says try these A. I want you to attempt that first problem somewhere on the bottom of your paper. You can do it after that last paragraph. We're not going to do all the questions. And if you're struggling, I'm going to give you a hint. You're going to take this and just plug it in where X is. Oh, that's one way you can do it. It's probably the easiest way. Okay, so we do not have to solve for y every time. Okay, that's what I want you to remember with this. I know you've been conditioned, like we're always going to solve for y, we're always going to solve for y. But in this case with systems, whatever is easier. So in this case, x is already solved for. So if I go down and I try to solve for y, I'm creating more work for myself. Okay? So go ahead and just plug it in how it is. Then we're going to solve. So I'm going to distribute. What's 4 times 25? 4 times negative 3y. Then what? Combine like terms. Negative 12 plus 5. I'm going to subtract 100 from each side. I get negative 91. Then I'm going to divide both sides by 7, which is what? How do I get the other number? Okay, plug it in. Does it matter which equation I plug it into? Not really. But the top one would be easier, right? What's 3 times 13? What's that? 25 minus 39. Okay, negative 14. How am I going to write it? Okay, so writing it as a coordinate point.